This is your friendly neighborhood physics teacher here, and we're going to talk about our spring demo here. So right now, it's in equilibrium. The reason I know that is because I have the mass here, and everything is balanced. Equilibrium just means everything is balanced. Now, if I add energy to it, so I'm adding energy to it. Basically what I'm doing is I'm stretching it. So from here, we have elastic potential energy. If I let it go, it's going to sit there and oscillate, go back up and down, up and down. Anytime it reaches that equilibrium, its kinetic energy is going to be at its max, and then it will compress up. I'll do it a little bit more without it, so you get a little bit better. There you go. Kind of see what's going on. Now, hopefully you can hear that horrible noise. And basically, that's the hook up there where I have it latched onto. It's taking away energy. I'm going to disappear now, since we kind of already visualize what's going on. And we're going to write out our equation. So again, think about what's happening at the beginning, what's happened in the middle. Like, think about the main parts. So when you have a mass and a spring, and you've stretched it down to here, this is going to be it's going to have max elastic potential energy. Because I've sat there and I stretched it. If it's here and it's chilling at equilibrium, so this is at equilibrium, you're going to have max kinetic, but since it's going up, it's gaining your gravitational. It's gaining gravitational. Now between here and here, you're going to have, so your elastic potential is getting converted into kinetic and also gravitational. And then you have up here where it's scrunched as far as it can go. When it's scrunched as far as it can go, again, it's going to have elastic because it's scrunched. It's going to have gravitational, and actually max gravitational, because that's as high as it can go. But thanks to that lovely sound, we're actually going to be taking away some work due to friction. And again, from here to here, as it's going up, you're going to be losing kinetic energy, or it's going to be gaining gravitational potential and gaining your elastic potential. So it's constantly changing. Now, from here to here is considered a closed system. It's when you add this into the mix, which makes it an open system. So if we're going to write out our big equation, we would have our elastic max would equal, or that elastic max that's being turned into kinetic and gravitational, equal our kinetic max plus gravitational would equal, again, that kinetic is getting turned into more gravitational and elastic, but this wouldn't equal. All of that would be greater than our elastic potential plus our gravitational max, that's as high as it'll go, minus the work done by friction. And again, that's going up, and you could do the same thing going down. So you would start out down here. You would start out with your elastic potential gravitational max minus work. But that would equal a new set of elastic plus kinetic plus gravitational. And that would equal a new kinetic energy plus gravitational. And that would equal a new kinetic energy plus gravitational plus elastic potential. And that would equal a new elastic potential at the bottom. So that's kind of what's going to happen. And then it would go back up. And then it repeats itself. So it kind of just goes a complete circle. But it's only max the first time because all of a sudden it's losing, because of this work, it's losing energy. So it's really no longer max. And it's just an even, so what I mean by even transfer. So if we think about like little energy bars. So all of the energy we have is in elastic potential right now. So all of that is elastic potential. There's 0 kinetic and there's 0 gravitational. Now here, some of it isn't, it's just according where it is, so I'm just going to make them all even. But all these, if you stack them on top of each other, should be the same height as that. Now, is it? Probably not, because it's hard to draw that. And then here, all your elastic potential is gone, and it's in your kinetic, which I'll make a little bit. It's in your kinetic. Nope, hold on. So this kinetic should be a little bit more, and your gravitational should be a little bit more. So kinetic, gravitational. And then again, it's going to go back to being even. So again, if you stacked all these up, they should all equal this big thing up here. I'm going to make it a little bit taller so it kind of might look like it. So it gets kind of even, transferred. Now, as soon as this, we would have elastic, we'd have gravitational, but we would lose with no kinetic. So we have elastic, we have no kinetic, we have gravitational, but our work would end up being negative. Probably not that big though. So our work will end up being negative. So it's taking away. So again, so instead of over here, having our elastic potential being this tall, it'd be shorter. So kind of maybe thinking about it in graphs so you can visualize a little bit more. No, you do not need to make the graphs. I'm just showing you to kind of help you visualize with the graphs. So all these graphs should be equal until this last one. This last one wouldn't be equal because you're taking that energy away. So hopefully that kind of helps with the spring. If you have any questions, please ask. Have a wonderful day. Bye.